This tutorial will show you how to prepare the optical image profiler for logging by demonstrating how to set up the interface and field instrument, how to link the trunk line and probe, and finally how to begin working with the DI acquisition software and run simple QA tests. To run the optical image profiler, you'll need to connect the OIP interface to the OIP field instrument. This connection is established with a 62-pin communication cable. These gendered receptacles are responsible for connecting the trunk line to the OIP interface. The lower connection is the control line, and the upper connection is the video feed. This cable with a 6-pin end and a 4-pin end establishes electrical connectivity between the OIP interface and the field instrument. The USB cable provides data connection for OIP mode from the field instrument to the back of the interface. The last connection that needs to be made on the back of the OIP field instrument is the string pot cable, which allows depth to be measured as the probe advances through the ground. The opposite ends of the trunk line have two different purposes. The end with the shorter wires connects directly into the control line and video feed cables attached to the OIP interface. The end with the longer wires is the downhole side that connects to the probe. You want to begin by feeding the long end through the drive head. Next, continue to feed it through the connection tube. When you connect the trunk line to the probe, the longer line with red and orange wires pairs with the shorter line on the probe, which has two red wires. That connection creates room to fit the OIP power module in between the other wires stemming from the trunk line and the probe. Once you make all of the wire connections, it is important to secure them with electrical tape. Without this step, the connections could come loose during operation, and you'll have to retract the probe. In order to fit the connection tube over the power module, you can do some overlapping with the wires, and you can bundle the loops using electrical tape. Covering the wires and power module with a liner can help protect them from potential damage. During the hammering of the probe, bare exposure to the inside of the connection tube could cause the wire insulation to wear and short out. Using a liner that is sliced will help you easily cover the wiring tightly. After you make the fitting, seal the liner up using electrical tape. Determine the point at which the trunk line will meet the top of the connection tube. This is a quick measurement, but a smart step for further protecting the trunk line connections. You can use electrical tape to create a strain relief for the water seal to push down on during probing. After this step, go ahead and fasten the connection tube to the probe. The next step is to apply the water seal and spacers before attaching the drive head. Using Vaseline or a lubricant on the water seal can help you fully tighten the drive head by hand. If it won't seal all the way and you have to use a pipe wrench to make more than a half turn in tightening the drive head, it could cause damage to the threads. The short end of the trunk line is best for weaving through the probing rods. Please note that it should always be fed through the female end of the rods. Briefly combining the wires with electrical tape can be helpful in threading the trunk line through these rods, and it can protect the connections from being damaged during this process. Once you have the trunk line through the rods, the final step in preparing the probe is to connect it to the control line and video feed cables that were attached to the OIP interface earlier. The first time you connect a computer to the OIP interface, you will first need to turn on the field instrument. Connect your data and video line to the interface and then plug them into the computer one at a time. Take a few seconds before plugging them in one after another so you can allow the drivers to load properly. After the drivers have loaded on your computer, turn on the OIP interface, and from there you can start the DI acquisition software. When the software is up and running, start a log. Before beginning the actual logging, there are preliminary QA tests to run. First, record a high and low test load of the electrical conductivity using a dipole tester. Next, you'll need the black test box containing diesel fuel and motor oil. First, hold the diesel fuel side to the sapphire window on the probe and capture its fluorescence. This will help you make sure you are seeing correct imaging. Do the same type of test and capture of the fluorescence seen from the motor oil. Next, use the hollow side of the test block to perform a black box test. If you see fluorescence in the image during this test, this indicates there are particles inside or on the window that need cleaned to prevent false positives in the log. The next test is a visual test to confirm clarity of the image and proper color. In this demonstration, the visible light source being used is a key tag, but a variety of small, flat items can be used for this. Finally, select the proper string pot and rod length being used and hit finish. We highly recommend you pre-probe the first meter of ground before you begin the actual log. After that, connect the string pot to the machine and advance the probe into the ground so the sapphire window is level with the surface. And when you are ready, turn on your trigger to begin logging.